Okay, so as you can see, I am taking this directly from your notes. It is the area between two curves, and I want to show you this region. What do I mean by trapped between two curves? It means that it is bounded on all of its sides. So in this case, this goes off to infinity, right? This one also goes off to infinity. This region here goes off to infinity, and this goes off to infinity. This is the only region that's trapped on all of its sides, right? If I put soup in there and shook it around, it wouldn't go anywhere, it wouldn't spill out. So that's what I mean by the region being trapped between these two curves, right? So in your notes it says g of x equals x squared plus 1, and then f of x equals 2x plus 4. Chances are these are the only things that you're going to be given, but you're going to have to figure out what happens at the starting point and the ending point, right? Those won't be given to you. So what you're going to do is you're going to get your calculator out and you will sketch out your original two functions. All right, so on the one hand, I have this one, y equals x squared plus 1. And the other one, I'm going to plug in y2 equals 2x plus 4. Please look at your notes so that you're not having to focus too much on what's in this written in this video. Okay, so once I have those two in there, I'm going to graph them. Okay, so if I want to find out where this region starts, which is this point of intersection, and where this region ends, it's the second point of intersection, then I'm going to find them one at a time. So second calc, we're going to go down to number 5, and we need to scroll near it. So enter, enter, enter. Tells me that x equals -1 is one point of intersection. I have that there. That's where that came from. Second calc, number 5 again. We're going to scroll over to the other point of intersection. Just needs to be near it. Enter, enter, enter. There's the other point of intersection, x equals 3. And there you have it. Notice I'm not concerned with the y values, but I am with the x. So we have to be really careful because we don't know how to find this so far, but what we can do is find out what happens between each one of our curves and the x-axis. So I'm going to do exactly that. I'm going to do them one at a time. Okay, so you'll notice that the vertical lines indicate the area that's trapped between 2x plus 4. The x-axis starts at x equals 1 and ends at x equals 3. So let me show you what that is. This region should be trapped between this function and the x-axis right there. Pinch, right? So we know it has to go like this. Just like that. Okay, these should be going all the way up to your function. Okay? So that is that antiderivative. Notice that's not this area trapped between the two curves that we have, but instead it's just from y equals 2x plus 4 down to the x-axis. All right, so let me show you the other one. So the other one, okay, you can see it in dots, this is the region that's trapped between x squared plus 1, which is the parabola, right? It's this. That. And the x-axis starts at -1 and ends at 3. So we can find that on our calculator fairly easily, right? That is this polka dot region in here. And hopefully you can see what Sal from Khan Academy was trying to tell you is that if we want to find the area trapped between the two curves, this, which is basically just this region here. Let me show you this region in here, right? Then we're going to take the red region and subtract off the black region. That's what Sal is trying to say. So there is a topmost function or an uppermost function, and there's also going to be a bottommost function, right? Where you're going to do top minus bottom. I think Sal does upper minus lower. Okay, what I typically do in order to find out what's on top and what's on bottom is I try to put a vertical line down, and whichever one of my functions is higher than the other is my top, the other one is going to be my lower. Okay, so to summarize, you should be able to take the area trapped between the function and the x-axis of 2x plus 4 dx from -1 to 3 and subtract off the area trapped between x squared plus 1 from -1 to 3 dx. And that should give you the area trapped between the two curves. So it literally is that simple, top minus bottom, right? That's what I typically do, and I'll write that down. This is the one that's on top, minus the bottom. Just like that. All right, according to what Sal did, mathematically speaking, and this is true in mathematics, if your intervals are the same, you're going from -1 to 3 in both cases, you should be able to smash these two together, right? And do it all at once. So let me show you that. So the integral from -1 to 3 of 2x plus 4, hold on one second, minus x squared plus 1 dx. This should give you the same thing as if you were to do them separately. So I'm going to do them on my calculator so that you can see that you get the exact same answer. All right, so let me do them one at a time. So on the one hand, I'm going to do this first one, right? So 2x plus 4, graph that. I'm going to do second calc, number 7. Lower limit is -1, upper limit is 3. All right, so I get 24 units of area here. Minus, all right, let's do the other one. So y equals x squared plus 4. I'm sorry, x squared plus 1. Okay, graph that. So second calc, number 7. Lower limit is -1, upper limit is 3. I get 13 and a third for that. So let me do the math on home screen. 24 minus 13.33, if you will. Oops. 24 minus 13 gives me 10.67, or 10 2/3. All right, so let me look at this other one, which says we should be able to smash this together. This is fairly common in mathematics. Put them together because they have the same interval and do it all at once. So I tend to do that, to smash them together, because it saves me some time. All right, so here what we have is, I always put parentheses, look, it says 2x plus 4, 2x plus 4, like that, minus parentheses x squared plus 1. Okay, and I'm going to smash it together. What you have to keep in mind is when you do smash these two together, it'll give you a function that's not necessarily going to look like either one of them. And it may not look like this trapped region, right? But it's going to represent this trapped region between the two curves, right? That 10 2/3 that you got. So let's see what happens. Let's graph it. Okay, so notice it doesn't look like what we have in the other videos. Second calc, number 7. The lower limit is -1. Upper limit is 3. Look at that. Same answer. 10 2/3. Okay, so please keep that in mind.